So welcome to the learning series, and we're looking at the new basic questions. So we'll cover 311 to 315 in this section. Any of the new questions are in bold. And also in this section, you'll find the formulas and block diagrams useful. So it comes in two parts. One is the study aid, which you can't bring to the exam, and the reference material, which you can bring to the exam. So this is the study aid where it actually gives you the formula and explains it to you, or gives you a diagram and explains it to you. But in the reference material that you can bring to the exam, all the words are gone. So all you get is the diagrams. So we're on 3 operations technical. And next week we'll get into electronics, and then the following week into electricity and components. So today we'll cover 11 to 15. So basically transmitters, carriers, FM, station accessories, and digital modes. Digital modes has also been updated quite a bit. So here's one. What does chirp mean? So that usually happens when there's a drift in the output frequency. And so that happens when there's a change in the output frequency of a transmitter each time a DIT or DAW is sent. What can be done to keep a CW transmitter from chirping? So usually this chirping is a result of a power supply that can't supply the current to the RF amplifier. So it doesn't give a steady level of voltage with varying currents. So you need a better power supply. So D is the correct answer. Here's a new question. What is the advantage of using a variable frequency oscillator in a basic CW transmitter? So the answer is that frequency is not constrained to the available crystals. So transmitters used to use crystals, and you were limited by the frequency of the crystal, and you would have a whole set of crystals for different frequencies. Here you would have a variable frequency oscillator, or VFO, that would allow you to adjust what frequency you want. What type of transmitter modulation changes the amplitude of the RF wave for the purpose of conveying information? So this is amplitude modulation, because the amplitude is varying. What is the emission mode? In what emission mode does the instantaneous amplitude or envelope of the RF signal vary? So again, it's amplitude modulation. Morse code is usually transmitted by radio as an interrupted carrier. So here with Morse code, the carrier is either on or off. A new question. You are transmitting using amplitude modulation, or AM. What bandwidth does your signal occupy if the highest frequency of your voice is 3 kilohertz? So because you're using AM modulation, you're transmitting both upper and lower sidebands, so it would be double that, so it would be 6 kilohertz. Now the new question, what frequency components are presented in the bandwidth of amplitude modulated signals? So here, what you get here with AM is you get the carrier plus the 2 sidebands. You get the upper sideband and the lower sideband. Another question, an RF oscillator should be electrically and mechanically stable. This is to ensure that the oscillator does not. So this is one of these not questions again. So the only one that makes sense here is it does not drift in frequency over time. Uh, the DC power to the final stage of your transmitter is 200 watts. The RF output is 125 watts. What has happened to the rest of the power? So in usually most of the cases, it's dissipated as heat because the amplifier is not 100% efficient. So some of it is converted to heat. Here's a similar question. The difference between DC input power and RF output power of a transmitter RF amplifier appears as heat. Now we get on to a single sideband. So what may happen if a single sideband transmitter is operated with the microphone gain set too high? So here what happens is the signal becomes wider and you may interfere with other stations operating near its frequency. What may happen if the single sideband transmitter is operated with too much speech processing? So you can either adjust the microphone gain and or the speech processing. So C again, it may cause audio distortion or splatter interference with other stations operating near its frequency. What is the term for the average power during one RF cycle at the crest of the modulation envelope? So this would be the peak envelope power, PEP. What is the usual bandwidth of an amateur radio signal, single sideband signal? So typically it's between 2 kilohertz and 3 kilohertz. Here's a new question. Why does the power amplifier of a single sideband transmitter need to be linear? That's because you want to amplify the signal as close to the input as possible. So the voice is unintelligible when amplified by a non-linear amplifier. If you only with a non-linear amplifier, you're only amplifying parts of the waveform. You ideally want to amplify the whole waveform. What is one advantage of carrier suppression in a double sideband voice transmission? So more of the output power can be put into the sidebands. A is the correct answer. What does overmodulation do to a single sideband signal? So it becomes distorted and occupies more bandwidth. E. How should the microphone gain control be adjusted for voice operation on a single sideband receiver? So you want to such that the maximum range on the ALC meter is never exceeded on the voice peaks. What is the purpose of a balanced modulator in a single sideband transmitter? So here the balanced modulator suppresses the carrier and passes on the two sidebands. A new question. In a single sideband transmitter set to operate lower single sideband at 7100 kilohertz with a single 1000 hertz tone as modulation, at which frequency is the RF transmitted? So here the signal coming out because you don't have the carrier anymore is actually at 7099. D is the answer. So you take 7100 and subtract 1 kilohertz from it. Remember, this is in hertz and this is in kilohertz. So it's 7.7099. The automatic level control ALC in a single sideband transmitter is C limits the input audio peaks so that the transmitter is not overdriven. A new question. Now we're getting into FM modulation and phase modulation, although phase modulation is generally not used in amateur radio. What causes the loud noise heard from a FM receiver in the absence of a signal? So that is because of a very large gain of stages ahead of the discriminator. Another new question, you're using an FM repeater configured with a 5 kilohertz deviation. What But your transmitter is set to 2.5 kilohertz deviation. What is the consequence? So because your signal is smaller than what the repeater allows, your audio will sound low. What term defines the change in frequency caused by the modulation in an FM transmitter? So here it's known as deviation. So that's how wide your peak is. What kind of emission would your FM transmitter produce if its microphone failed to work? So in this case, you would be transmitting an unmodulated carrier. Why is MF voice best for local VHF, UHF radio communications? The answer here is D, because it produces a good signal to noise ratio at RF signals. What is the approximate bandwidth of a frequency modulated signal using a 5 kilohertz deviation? So the answer here is between 10 kilohertz and 20 kilohertz bandwidth. How is the highest level of a modulating signal represented in an FM signal? And it's by the larger excursion of the carrier frequency. What modulation method is most closely related to frequency modulation? So in this case, it would be phase modulation. Why isn't FM used as an amateur radio emission mode below 28 megahertz? And that's because the bandwidth is too wide and would interfere with a lot of stations, and it exceeds the limits of the regulation. So C is the answer. The bandwidth would exceed limits in the regulation. Several stations report that your FM transmission is loud and distorted, but on frequency. Which one of the following most probable causes of the distortion? So the simplest one here is you're speaking too loudly into the microphone. So move the microphone away from your mouth, or speak more softly. When more than one signal is present, the FM receiver is likely to demodulate only the strongest signal. What is this behavior called? And so this is known as a capture effect. So only the strongest signal gets demodulated, and you won't hear the other. You wouldn't even know that the other signals are there. Now we get to station accessories. Why do many amateur radio stations use? What do many amateur radio stations use to help form good Morse code characters? And what they would use here is an electronic keyer. There is a new question. How does the electronic keyer help form good Morse code characters? So it does that by regulating the lengths of the dits and the dots. Another new question. What do you need to adjust before using your microphone for the first time on the transceiver? So this is your microphone gain level. Another new question. What noise management system analyzes noise and signal characteristics to partially remove noise? So here you've got a choice. So in this case, it would be your digital signal processor noise reduction. What circuit causes a transmitter to automatically transmit when an operator speaks into the microphone? That's known as VOX. What is the reason for using a properly adjusted speech processor with a single sideband voice transmitter? So your signal, your speech processor improves the intelligibility of your signal. So B is the correct answer. In a single sideband voice transmitter is 100% modulated. How will using the speech processor affect the output? So with the speech processor, it will increase the average power going out. However, if you have too much speech processor, you do not get more power. You just distort your signal. A new question: in a receiver, what noise management circuit recognizes high amplitude, short duration pulses and removes it? So in this case, this would be a noise blanker, A. What type of interference is a noise blanker circuit most effective in eliminating? So noise blanker is good for short duration impulse type noise. What is the function of a transmit receive switching in a transceiver? So that's D, to enable one antenna to be used for both transmitting and receiving. What type of microphone has an internal component similar to a loudspeaker? So that would be a dynamic microphone. Uh, Now we get into the digital modes. So quite a few of these questions have been updated, and a lot of the old things referring to packet and TNC have been removed and refers to the more common digital radio signal where you use sound cards. Why can or a modem? Why can a modem digital radio system transmit voice and images and not just data? That's because any analog signal can be converted to digital data. What is the fundamental difference between digital and analog data? So this is a new question. So digital data is encoded as discrete, prearranged values like ones and zeros. We'll see is the correct answer. What is the function of a digipeater? So a digipeater is the same as a repeater except for digital signals. So it's to receive digital data, transmit data, and retransmit data marked for retransmission. What does network mean in packet radio? So here it's a way of connecting packet radio stations so data can be sent over long distances. So you create a network of radio stations or transceivers. Here is a new question. Why can dozens of FT8 communications occur simultaneously in the space needed for one single sideband transmission? And that's because of the narrow bandwidth of the FT8 signal. Another new question. Which of these modes can work at the lowest signal to noise ratio as measured with a 2500 hertz bandwidth? So this would be FT8. So B is the correct answer. When selecting an really transmitting frequency, what is the minimum frequency separation from a contact in progress that you should allow center to center to minimize interference? So for a RIDI, the answer would be D, 250 to 500 hertz. A new question. So this is one of these not questions. When using a digital mode based on a computer sound card, how can you verify that the transmit audio signal audio level is not excessive. So the way you can do that is ask a local station to confirm your signal is free from splatter. Another question here, what feature of packet radio makes it especially useful for emergency communications? And it uses reliable messaging, so that's guaranteed delivery or notification of failure. Another new question, the digital protocol implements automatic repeat request, ARQ. What does it permit? So ARQ is used for error correction. So C is the correct answer. When a digital communication mode based on a computer sound card, what is the result of feeding excessive audio into the transmitter? So here, it's the same as with your microphone. If your audio signal is not set up properly, you create splatter or out of channel emissions. So that concludes this section. So let me just stop this recording and then we'll get to the next section. Stop recording.